All right, we are now live. Very warm evening to all of you, or good morning, depending on which part of the world you're from. Uh, I want to warmly welcome you to our webinar, which is on data science and its real-world applications and case studies. As you all know, data science is one of the most upcoming sectors of the industry, one of the most prominent things that is taking the industry by storm. And today, our speaker will be sharing a lot more on how that's happening, how data science is affecting the real world. What are people implementing in the real world that is, changing business? So, uh, in order to take up today's webinar, I'd like to introduce our speaker before passing the mic to her. So today we are very honored to have Kelly with us from the Philippines, who is a seasoned data science expert, DevOps engineer, and many other things, right? It's a numerous list. I don't want to go through it. But she has worked with numerous organizations in the past, is currently working with a French multinational company as well, as a data science and DevOps engineer. And she has a lot to offer. She'll be able to guide you through how data science is revolutionizing industries today, and what are some of the key applications to look out for in terms of utilizing data science more efficiently. So today's webinar is going to be about 45 to 50 minutes, and post that we will be having a Q&A session. So do make sure to wait up until the end if you want to ask any questions, and we will be discussing a lot of things with Kelly as well. So Kelly, the floor is all yours. Please take it away.
Thanks, Aditya, and thank you everyone for those who attended to this webinar. So, hello, good morning, afternoon, or evening from wherever you are right now, in which time zones. So, I'll just share my screen for this presentation. Okay. So our topic for today is data science in action, real world applications and case studies. And this is going to be an exciting part for me because I would be able to share its applications in real life, how it helps a lot of industries, people in technology, how would it make our life more easier and faster. So objectives here is to define data science and understand what data scientists do, to understand big data challenges, to know real life applications and case studies and how it's being applied, and to know why big data is better data. And for the outline, I'll be defining big data science, and what does data scientists do, and some of the differences between data science, machine learning, software delivery, analytics, and with big data as well, how data science is applied in many industries, featuring case studies, examples, data science, big data, challenges, and then data science, other connected to it and its differences and its key takeaways. So for this one, this is a very common quote from Clive Humby, a British mathematician and chief data scientist at StarCount. So data is the new oil. So this phrase, data is the new oil, emphasizes the immense value, abundance, and transformative power of data in today's digital age, highlighting its potential to shape industries, economies, and societies. So, like oil, data has become a valuable resource in the modern world, right? So, it has the potential to drive significant economic growth and innovation. And similar to the vast reserves of oil in the ground, there is an immense amount of data being generated every day. And by extracting the value from data requires the right tools, techniques, and expertise. For big data and data science, here are some reports that I got from some of the research. The sexiest job in the next 10 years would be a statistician. And of course, in data science, it involves statistics, math, probability by Google chief economist. And in the US, it reported that US will need 140,000 and 290,000 predictive analysts and 1.5 million managers analysts by 2018, reported by McKinsey Global Institutes in June 2011. So, and then there's another report that new data science institutes are being created and repurposed, and then new degree programs and courses. So in every country, they are developing a lot of data science, and it is really hype right now in the 21st century when it comes to jobs, when it comes to offering programs to universities. Some are really budgeting a lot to improve more the data science, artificial intelligence sector in respective fields as well. So now now we're going to talk about the difference of data science, big difference of data science and big data. So big data, as you can see here, is it refers to the vast amount of structured and unstructured data generated from various sources such as social media, sensors, devices, and business transactions. It is characterized by the first one, the volume. The second one is the velocity. The third one is the variety of data that exceeds. And the fourth one is the veracity. So first one is the volume or the scale of data. So volume it refers to the sheer amount of data generated and collected. So big data is characterized by its massive scale, often measured in petabytes or hexabytes. And then velocity or analysis of data flow, it refers to the speed at which data is generated, processed, and analyzed. So big data is often generated in real time or near real time from various sources such as sensors, social media, and transactional systems. It requires efficient data capture, streaming, and processing technologies to handle the fast flow of data. And for variety or the forms of data, it refers to the diverse types and formats of data that make up big data. So this includes, this one includes the structured data, example, the databases, semi-structured data, example, XML or JSON files, and unstructured data, example of these are text, images, and videos. And lastly, the veracity or uncertainty of data. Veracity refers to the quality and reliability of the data. Big data often includes noisy, incomplete, or inconsistent data from various sources. So this one is ensuring data veracity involves addressing data quality issues, managing data accuracy, and maintaining data integrity to ensure reliable analysis and decision making. So these four V's provide a framework for understanding the unique aspects of big data and the challenges organizations face in managing, analyzing, and deriving value from large and complex data sets. So in data science, it is a multidisciplinary field that combines statistical analysis, machine learning, and domain expertise to extract insights, patterns, and knowledge from data. So it involves collecting, cleaning, analyzing, and interpreting data to gain valuable insights and support decision-making processes. So in summary, big data and data science are interconnected concepts. Big data provides the raw material, while data science encompasses the techniques and tools used to extract meaningful information from big data. Let me just check again my slide. I think I'm having some issues. Okay, so this is what I've skipped. Okay, so let's take a look at this with a day in your life on how data science is applied in day-to-day life. You think about your life every day. Like example, what is the best road to take? So in data science, it can also be applied in transportation. It can help predict traffic congestion, optimize transportation routes, and forecast public transportation demand. Second, would there be any bad weather? Data science plays a vital role in weather prediction by analyzing historical weather patterns, atmospheric data, and satellite imagery. Third one is how to invest your money in finance. It can also be applied data science in there because it can assist in predicting stock market trends, forecasting asset prices, detecting fraudulent transactions, and assessing credit risk. And lastly, how is your health? In healthcare, it can be used a lot. And later on, we'll tackle about its case studies. So in healthcare, it can use to predict disease outbreaks, identify high risk patients, and forecast patient readmission rates, and predict the effectiveness of different treatment options. Okay. So here is an illustration about the data science and its many definitions. So for this one, we can see here that the other definitions focus more on technical skills alone. So you can see here the illustration, and on the other hand, other definitions focus more on this side. um, for this next slide. So for this one, what does data scientists really do? So first is that now that we define well what is the difference of big data and the data science, how it is being applied in many industries, I give some examples. Now, many of us are wondering because there's a lot of definition on the internet. What does data scientists really do? So first one, they analyze large and complex data sets. Why? It is to extract insights and solve complex problems. Second, they use statistical techniques and machine learning algorithms. It is to identify patterns, trends, and correlations in data. And then they clean and pre-process data. It is to ensure its quality and suitability for analysis. And the next one is to perform exploratory data analysis. It is for them to understand the main characteristics of the data and generate hypotheses. And then next one is to conduct feature engineering. So data scientists, they develop and implement machine learning models to make predictions, or for feature engineering, it is used to transform raw data into meaningful features for model training. And they evaluate performance of machine learning models and collaborate with domain experts and stakeholders. And for this one, next is stay updated with the latest advancement of the technology or different algorithm techniques that could be used for the models, and adhere ethical guidelines, work with interdisciplinary teams. So this is what data scientists do, but it would depend with, well, some companies, actually some of the job or responsibilities that they describe on their description, sometimes it's much more than this, depends on if it's entry level or mid or it's a senior. So there's a lot of tech stack that you would need to know in terms of programming languages, in terms of algorithm techniques, in terms of uh, math and such. Now, let's talk about data science real life applications. So this one is an example, a case study about real time soccer analysis. So this case study focuses on the application of real time soccer analysis to improve team performance and strategic decision making in professional soccer. So sports analytics. So by leveraging advanced data science techniques and technologies, the team aims to gain valuable insights from live match data to enhance player performance, optimize team strategy, and ultimately achieve better results on the field. So this project involves the collection of real-time data from sensors and tracking devices placed on players, which capture various metrics such as positions, movements, patterns, speed, and ball possession. So these data points are continuously transmitted and processed in real time using powerful data analytics and platforms. So the data scientists apply machine learning algorithms to it and statistical models to analyze the live data streams and extract meaningful insights. So, like example, the real-time soccer analysis provides immediate feedback to coaches and technical staff, enabling them to make data-driven decisions during matches. So the insights derived from the analysis also contribute to long-term player development and training strategies. So overall, a real-time soccer analysis serves as a powerful tool for enhancing team performance in sports, optimizing strategy and gaining a competitive advantage by leveraging data-driven insights. Like example in NBA, they have a data scientist there where they study the data of each of their players for each teams. So imagine how cool was that if you want to major like sports analytics or to study some of these in the future, or if you're a professional and wanted to try out this career path. And then for the next case study, okay, so use case big data for development. So now you can see here is the good example for urban planning. So how is big data used for these kind of um, use case, like for urban planning? So example, urban infrastructure planning, big data analytics can provide valuable insights for urban infrastructure planning by by analyzing data on population density. Oh, sorry, having some issues with my laptop, I think. Okay, for urban infrastructure planning, by analyzing data on population density, transportation patterns, energy consumption, and water usage, urban planners can make informed decisions regarding the design and development of infrastructure systems such as roads, public transportation, utilities, and waste management. So this could really help on planning goals and objectives to clearly define these urban planning. So um, first, how do they do these kinds? So first, they identify and collect relevant big data sources for urban infrastructure planning. And for the data integration and processing, they integrate process the collected data to create comprehensive and unified data set. So this is a very helpful one, and the one application of big data for development. Data science case study for cancer research. So This is very one of the very interesting part, especially in the healthcare industry, is to with these kind of case studies. So access to comprehensive. So here's the example. So there's a research scientist at Purdue University. They use data science to help discover how the next generation of treatments for cancer may be found. So they've been studying it a lot, and based from the research to the latest available data from WHO in 2020, imagine cancer accounted for an estimated 9.9 million deaths worldwide, and the data integration and management, computational infrastructure resources, huge amount of data processing and recognitions. So access to comprehensive and high quality data sets is crucial for in healthcare or for this field. This includes genomic data, clinical records, imaging data. So it's going to be a lot, molecular profiling information, and other relevant data sources. So effective integration and management of diverse data sets are necessary. So this may involve high performance computing, clusters, cloud computing resources, GCP, AWS, or maybe Azure, or specialized hardware for efficient data processing and analysis. So for this case study, by addressing these requirements, researchers can effectively apply data science in cancer research studies, leading to deeper insights, improve understanding of cancer biology, and advancements in diagnosis, treatment, and patient care. So that's going to be the future once this research really develop in many years to come. Next one is a data science case study for Internet of Things. So Internet of Things is rapidly growing. It is predicted that more than 25 billion devices will be connected by 2020, and IoT will soon produce a massive volume and variety of data at unprecedented velocity. So if big data is the product of the IoT, data science is its soul. So real life application of Internet of Things. I remember I was doing a one project back then where it's for farms, and we needed to use IoT like to detect if the the crops are will be flooded once there is an incoming typhoon, something like that. So I cannot explain more deeply because, uh, sorry. Okay, so real life applications of IoT, it can apply to many industries, but I'll give a few examples of it to be able to understand how it's being applied and how it's really cool to apply in these specific industries and could make a very huge advancement. So first one is in healthcare. So IoT devices are being used in healthcare to monitor patients remotely. So it can collect real-time data and enable telemedicine services. This allows for proactive and personalized healthcare, improve patient outcomes, and reduce hospital readmissions. So IoT devices such as wearables, remote monitoring systems, and smart healthcare infrastructure are enhancing patients' care and streamlining healthcare operations. So that's how our IoT is powerful to some of these specific industries that I've mentioned. So in agriculture, so uh, IoT-based solutions are transforming agriculture by enabling precision farming, smart irrigation, and livestock monitoring. So sensors and actuators embedded in fields and farming equipment uh, collect data on soil conditions, weather patterns, and crop health. So the project that I've worked on before is related to this one in agriculture. We've used IoT. And then manufacturing. IoT technology is driving the concept of smart factories and industrial automation. Connected sensors, equipment, and machinery. It can enable real-time monitoring, predictive maintenance, and process optimization. So, and next one is smart cities. So, IoT deployments in smart cities leverage connected devices to enhance urban infrastructure. It improves resource management and enhance the quality of life for residents. So, this case study showcases how the IoT is transforming industries by connecting devices, enabling data driven insights, and revolutionizing operations. So, with its ability to gather and analyze vast amounts of data, the IoT is empowering businesses, improving efficiency, and creating new opportunities for innovation. So next one, we have next case study, customer analytics. So in customer analytics, its real life application is that um, first one, we have descriptive analytics. So descriptive analytics focuses on summarizing and understanding historical customer data. So actually, this customer analytics, this could be also used in digital marketing. So I have one experience before where we've studied some businesses and it helps a lot because of their customer analytics. So we've studied it and we've helped them improve their businesses to be able to step up their game on their profits and such. So it can really help a lot. So going back to descriptive analytics, so it focus on understanding historical customer data. And the next one is for the diagnostic analytics. It focus on summarizing, understanding, or gaining insights. And for predictive analytics, it uses historical customer data and statistical modeling techniques to make predictions about future customer behavior. And prescriptive analytics takes predictive analytics a step further by recommending actions or interventions to optimize customer outcomes. So it is customer analytics. It is to optimize business operations and drive decision making in various industries. So now we are going to big data and data science challenges. We're gonna tackle this one by one. First, big data often comes from various sources with different formats, structure, and quality. So handling large volumes of data requires scalable infrastructure and computational resources. And for scalability and so that's the first one here, the data quality and data integration. So it can large volumes of data requires scalable infrastructure and computational resources. And then for data privacy and security, with a vast amount of data being collected, protecting the privacy and security of sensitive information is critical. And the fourth one, data storage and management. Big data necessitates effective data storage and management systems and talent and skills gap. So the demand for skilled data scientists and professionals with expertise in big data technologies often exceeds the supply. So that's the uh, this is the one that challenges the big data and data science. Now we're going to, this is an illustration for comparisons of data science, analysis, and software delivery. So you can look at this one while I'll explain it further how it is being different to each other. So data science, it focuses on extracting insights and knowledge from data using scientific methods, algorithms, tools. It involves working with large data sets, applying statistical and machine learning techniques, and utilizing programming languages like what is put here, like Python or R. So in analysis, it involves examining data to understand its meaning, significance, and implications. So it encompasses breaking down complex information, identifying trends, patterns, and relationships, and drawing conclusions. So analysts use statistical techniques, data modeling, and visualization tools to explore and interpret data. And lastly, in software delivery encompasses the processes involved in creating and delivering software products or solutions. So it involves the entire software development lifecycle, including requirements gathering, design, coding, testing, deployment, and maintenance. So that's the difference of these three. And I hope this illustration could help you see more and take notes of it. So while data science and analysis focus on extracting insights from data, software delivery focuses on building and delivering software solutions. However, there are points of overlap between these areas. Like data scientists and analysts may develop software tools or models to facilitate their work, and while software teams rely on data analysis to inform decision making and improve their products. So that's how it works sometimes. And next one, it's comparison between data science and machine learning. Let's start first in machine learning. So machine learning is a subfield of artificial intelligence that focuses on developing algorithms and models that enable computers to learn from data. While on the other hand, data science again is a broader field that encompasses various techniques, methods, tools used to extract insights and knowledge from data. So that's the difference between at these two. And then for uh, data engineering, as you can see here, data engineering is really more on an engineering approach. So sometimes, so as you can see here, data science is a scientific approach where you can like explore data, work with algorithms and such. While on data engineering, it's more of a kind of a back end part. So they are the ones who will develop pipelines, and data engineering works as well with cloud infrastructure. Like example, you're a data engineer and you need to create pipelines with the use of cloud computing platforms, whether it's Azure, whether it's Google Cloud Platform and such. And and um so that's all with its differences from each other. And key takeaways for this one is that uh, data science enable data science enables organizations to predict future outcomes and trends based on historical data. Second one, big data and data science or interconnected concepts. Big data provides the raw material, while data science encompasses the techniques and tools. And there are many possible future breakthroughs in different fields through data science, like in the case studies that we've mentioned, like for healthcare, for sports, There's a lot of it. And with more data, it allows us to see new. It allows us to, with big data, with big data, it could be like bring us a better data to see more of it, think outside the box, be what could be a new problem to solve in different fields of technology or different fields of industries. And here's the reference that helped me out to simplify this presentation. And that's a wrap of my presentation. So feel free to ask questions if you want.
All right. Thank you, Kelly, for that wonderful presentation. I think as part of the presentation, you saw multiple industry sectors, sports, healthcare, and many others, and how data science is, applicable to each of these sectors and is, creating a difference. We are now open to any questions, both on Zoom as well as our live platforms. So if you have any questions, please put them down here and we'll be very happy to answer them. We have about 15-20 minutes or so. We can go through any questions that you would have. Now, I think one of the questions that came in earlier, I think Rishabh had asked that question. What is, the ideal size of a data set to be called a large data set? Kelly, you want to try to take that one?
Okay. So for the ideal size for of a data sets to be called as big data, it should be a 10 times more than the number of degree more 10 times more than the number of degrees of freedom model has. So that's how I'm going to interpret it. It's really large. So I hope I've answered your question.
All right. Thank you, Kelly, for answering the question. Right, let's say if we have any more coming in, please feel free to put in your questions if you have any. So Rishabh, yes, it could be millions of rows or trillions of rows. The size of data really depends on, or what could be called big data really depends on a few factors. There's not a particular number that, a number of rows that is defined. Rather, it's based more on the capability that you have in terms of processing and storing the data. So anything beyond, what you have, typically in a raw context can also be termed as big data. But also, as Kelly mentioned, based on degrees of freedom of your model, if you have a multiple of that, then in that case, you could term it as a large data set. So lots of rows of data, right? Right. I think there's another question from Philip, who asks, how do we handle data privacy? So I think, Kelly, in your experience with the projects that you've done in the past, I'm pretty sure data privacy, would have been a big thing, especially with data science projects. So how was it handled as part of your projects? What's your take on that?
Actually, when I was trying to work in a computer vision project for facial recognition, may it be my personal or with experience in the company, we always make sure that the data has a consent from the persons that we are getting from, especially if it's images. So that's we always ask for their consent for it, for their data privacy. Of course, we wouldn't like get these data without their consent, especially if it's information. So I know this could be it could be there could be an instance where there could be a breach for data privacy, and we wanted to make sure that all of its data that we are studying are all safe, and it's with purely with consent from the people. So that's what I've experienced in my previous job.
Alrighty. Thank you, Kelly, for your take. So, I mean, data privacy can entail a number of things, as Kelly mentioned. You always take user consent in case you're collecting personal information or you have information that you do not want to share. Um, there are other ways, of encrypting the data, and so on, which can help you with data privacy. Different parts of the world have different data privacy laws that are enforced, um, and organizations, have to follow that as part of utilizing data. Right. So I have a few more questions coming in. Let's see what those are. Can a data set of 10,000 rows be considered as a big data set? I mean, that's a very interesting question. Kelly, what would you say to that?
Well, for me, from what I have experienced in my previous jobs, it is a big data set. Yes, it's 10,000 rows. It can be considered a big data set.
Yeah, so I think it really depends on how you're utilizing it and what is the hardware capacity as well. So there are a number of factors to define that, Joshua. Now, you'll have to take into context, where you're processing it. It's not only the number of rows, but what is the breadth of the data as well. That its depth is one factor. So multiple factors can define that. So Joshua, yes, in some situations, no in others. I mean, that's the fitting reply for you.
Yeah.
Um, yeah, Kelly.
Just to add, Aditya, regarding the 10,000 rows, well, especially in geo mapping, it could be large. The size of data, so it could be the one factor. So that's what I'm that's what I want to say specifically, because last time I worked with geo mapping, and it has a lot of data points. There's a lot of rows, even if it's like a big size of data. And sometimes your computer hardware would be so hard to process it because of its size, even if it's just 10,000 rows. But usually, big data sets would at least, uh, like example for an e-shopping company, or something like e-shopping to study their products, sometimes they could get at least a million to 100 million rows, and it would be considered as big data set, just to add information.
Thank you for the insight, Kelly. Joshua, hopefully, that adds a little more to your question as well. Uh, okay, I have another question here. I think this was based on one part of the presentation on Internet of Things. So Ernest says, or Nigel, rather, Ernest Nigel, he says, Internet of Things was mentioned in the presentation. Can you tell us a little bit more on what the concept is and what it means? So Kelly, do you want to take that one?
Yeah. Ernest, Internet of Things is actually, these are the one that embedded with sensors. So it is a hardware. So it is combined with hardware and software. It is embedded with sensors, software, and other technologies. Like example, wearable watch. That's an example of IoT. And with that, there's a wearable watch that could detect your heart rates, your stress levels, and such. So that's what we call Internet of Things. And then after that, you can connect that to your phone. As you can see, you have your health analytics there, and we can predict how much we can actually predict the health status of a person. So especially in patients as well, you can monitor them remotely, so it can be much easier for them. And just like what I've mentioned before, um, I've worked with some project in agriculture where we put sensors in specific areas. So those sensors are in hardware and it's programmed using a software or a code, and it is connected with cloud computing platforms like example Google Cloud platforms. So the infrastructure was designed there. If the sensor was able to get the data, like if there is an incoming flood attached to that one place, it will tell you, or it will gather the data when is the root crop will be like yeah, just like the project now, something like that. So there's some sensors, so it will tell you when it will be like you know, the root crop will be the specific root crop will be destroyed by a flood, so it is to prevent. So those are the example for internet of things. So I hope I answered your question well. So
Thank you, Kelly. I think that makes complete sense. So just to summarize that answer, Internet of Things is to understand is quite simple. Things around you that have connectivity to the internet and is transmitting information uh, comes under the category of Internet of Things, right? So it could be your smart watches, as Kelly mentioned. It could be a washing machine. It could be any appliance. Everyday objects that um, help you with information and draw some outcomes from that. All right. Another question that has been sent in by Alan is, will data scientists who work on disease outbreaks be considered as epidemiologists, or are they distinct from them? Maybe I'll take a little bit on that first, and then I'll get Kelly's opinion on that. Um, See, Alan, since it's a very niche field, right? So epidemiology is a very niche field, and uh, there's a lot of understanding required for someone to work in that field. Data scientists or analysts who are not very experienced with the subject matter may not really be may not really do a good job in that particular field. So epidemiologists, they specialize in knowing about the subject matter, framing hypotheses, coming up with the research, and then ultimately following a process, they come up with an outcome. So the primary difference would be this, in that the subject matter comes into play, and data analysts or data scientists who work on disease outbreaks might not necessarily know completely in depth on the subject matter as epidemiologists. uh, okay, that's my take. Maybe Kelly has a different one. Kelly, you'd want to try to pitch in your answer to that?
uh yeah, actually, I agree with Aditya. So usually data scientists who work on these diseases, they are not considered as epidemiologists. It's, if you're a data scientist, what you can do is, maybe if you want to study what epidemiologists do to help them, you know, uh, to help them advance more with their field, you can just make a collaboration with them to gather more data. And you, as a data scientist, you'll code it, you'll do statistical modeling with it, you'll do analysis with it, you'll gather a lots of data sets for you to be able to create a machine learning model that could help epidemiologists to like solve one of their problems. So that's my take on that.
Right. Thank you, Kelly. I think that's a great addition. Um, all right. So hopefully that answers your question, Alan. I have a question on live stream and on Zoom as well that are quite similar. I'm going to put it together. The question primarily is asking about the skills required to master data science, or what are the skills required to become a data scientist or an analyst? Kelly, maybe you can pitch in your take on that.
Yeah, well, for me, in my own opinion, I was a self-taught data scientist. That's my first job actually before I shifted from data science to DevOps engineer to cloud and so on. So I was able to learn first at least programming languages for beginners. This is actually if zero knowledge from data science at all. For beginners, you need to at least choose one programming languages. Don't let don't let yourself feel overwhelmed because you will get burned out. At least one programming languages either with R or Python, because these two are most commonly programming language that is used for data science. And then second is for you to know the machine learning algorithm techniques, or for you to know the supervised and unsupervised learning, the basics of all machine learning techniques. It is very important to know even just the foundations. So there are free learning platforms just like Coursera, data camp, where you could learn data science on your own. It is all free. So next is that you should also learn a bit of something about statistics. It's highly important. And at least visualizations. Those visualizations, of course, when you're gathering data, you need to clean the data. You gather data, you clean the data, and you need to know specific tools. How would you clean your data? Maybe it's by coding using Python language, using Excel tool or such. And you also need to, once you clean the data, you also need to know how to visualize it. You should know at least tools, visualization tools for data storytelling, such as Tableau, Power BI, such as that. That's just for beginners, so that's where you can start. But programming, foundational of all of it, especially with Python or R, is a must for a data scientist. And those libraries, if you know how to manipulate if you know how to use it well for each libraries, for especially for Python for your specific project, and then you're good to go for to be a data scientist. So don't get yourself into a much pressure to learn everything, because it would get you overwhelmed. Just at least uh step by step process. So that's my take on that.
All right, thanks, Kelly. I think one of the most important things that you mentioned was don't get overwhelmed with the amount of tools and technologies in data science. I think rightly there are a lot of tools and technologies out there, but if you learn a few, the knowledge that you gain from one can be transferred to the other. So pick a pathway that you'd want to take up and then just go with that. I think on that note, there was another person who had asked us whether we offer a boot camp, and this was on the live stream. His name is Jason. So we do offer our own boot camp as well, where we emphasize on all these different tools to be a data scientist. And if you are interested, you could always sign up for that. Uh, our counselors can get in touch with you, and then you can talk to them, get more information if you need it. So definitely possible, Jason, and anybody else would be interested as well. The question that is coming in is from Peter, who says, can cleaning of data done with Excel alone, or can cleaning of data be done with Excel alone without needing to use any other programming tools? Kelly?
Hi, yes, cleaning data can be done in Excel. So it's up to you. If you would like to use Excel for data cleaning, there are some formulas that you can use. Excel is a really wide tool actually. Sometimes you don't need to code it in Python just to clean the data. But for me, um, if you've mastered programming languages, especially Python, it would be better as well, because there are some few lines that could do all the work and automate things as well if you code it in Python. So yeah, just to add, automation is really important to data scientists, especially if you master the programming part. It could lessen your workload as well.
All right, I think Peter, that would have given you an answer. So Excel can definitely be used, but if you learn programming, that can give you an edge in terms of automating a few things or greater flexibility as well. And since Kelly, you spoke about Python earlier, maybe another question that is coming in can be answered related to that as well. So, which Python libraries can be used for spatial data or to work on spatial data? Maybe you want to give your take on that?
Yeah, sure. So I had that experience before working with spatial data, but that was a long time ago. From what I remember, what I've used was um, GeoPandas. So it's like pandas meet G's and NumPy, pandas and Matplotlib. That's what I've used for spatial data. Hope that helps.
All right, Lakshan, maybe you'd want to go try some of those libraries out and give us your feedback on how those went for you. Okay. As a beginner, this question is from one of the candidates on Zoom, which says, as a beginner, is there a recommended career path that would lead us to become a data scientist? Maybe I can, take a little bit of that and Kelly can add on. So, see, for people who are beginning their journey in data science, firstly, it's very important to have and nurture an interest in this particular area, right? Uh, Typically, you would, start off, like every other computer engineer or computer programmer does. You'd start learning the fundamentals of algorithms, fundamentals of, computational thinking, because these are, important foundations to be in the data science field. Now, as Kelly mentioned in some of her slides earlier, data science is a process that contains a lot of things, right? And typically, as a beginner in data science, you would, work with small amount of data. You would need to learn how to, clean it. You would need to know how to do some sort of analysis, and then you would scale up to, do machine learning and so on and so forth. So, you know, start off by probably learning some of the simpler tools out there. Excel was mentioned earlier. There are tools like Power BI, for example, that could help you. Some of these tools are easy to pick up tools because they don't require a lot of programming knowledge and can be used to do some sort of data cleaning, data visualization, analysis, and you could pick these up in a few days. Now, further to that, if you think you want to do much more, then picking up programming languages like Python would definitely help you, because it has a lot of libraries spanning across different parts of what can be done in data science. That includes cleaning, machine learning, deep learning, and so on. So starting from if you are a beginner, starting from the very basics of algorithms, going into simple tools and then scaling it up from there could definitely be the right path for you. In the industry, tools depend on the enterprise. There could be enterprise software that is being used. There could be open source software that is being used. But whatever you learn, as we mentioned earlier, everything is transferable. You have transferable skills that you pick up. So, you could always apply one to the other. That's probably some of the things that I would do. Maybe Kelly, what's your thought on that?
Well, for me, the fundamentals, I do agree with Aditya. And it's just for me, don't forget your fundamentals. It is very important when you grow in your career path as a professionals. So that would be all for this one.
Great, thank you, Kelly. So fundamentals are really important. Make sure you learn the fundamentals and have a strong foundation, right? I think while we're on that topic, people on the live stream have a question related to artificial intelligence. Primarily, what they want to know is there a connection between data science and artificial intelligence? I think we hear these terms, quite often. People are sometimes confused. Hey, is data science and artificial intelligence the same thing? Are they different? What would you say to that?
For me, yes, data scientists contribute to the growth and development of AI. They create algorithms designed to learn patterns and correlations from data, which AI can use to create predictive models that generate insight from data. So data scientists also use AI as a tool to understand data and inform business decision making. So that's my answer.
Great. Um, Thank you. So hopefully that answers the question. And I think nowadays you'll hear a lot more of artificial intelligence, out there, because there's a lot of hype about generative AI, chat GPT, and AI. The terminology is coming up quite often, but I mean, don't forget, everything is under the same umbrella. Artificial intelligence is a niche. So everything requires data at the end of the day to function. And without that, there can be no intelligence created artificially. So remember that. All right. I think we have just enough time for another one or two questions. If anybody has any more questions, please put them up either on the Zoom chat or on the live stream, wherever you're watching this webinar from. Do remember in the meantime that if you want to rewatch the webinar, they are available on all our social platforms. So YouTube, Facebook, Twitch, LinkedIn, and so on. So you can always rewatch them there. All right, let me see any more questions coming in. Guys, we have another 1 or 2 minutes. This is your last opportunity to ask Kelly any questions you may have, so that she can help you answer them and guide you if required. Okay, I think we'll take this up as a last question. Dennis says, what is the difference between supervised and unsupervised learning? I think we're going into a little bit of technical details, but maybe we can still get to that very quickly. Kelly?
Yeah, sure. Okay. So for the main difference between supervised versus unsupervised learning is the need for labeled training data. So supervised machine learning relies on labeled input and output training data, whereas unsupervised learning processed unlabeled or raw data. So that's the difference between those two. I hope I've answered the question.
Yeah, absolutely. So hopefully, whoever asked that question, Dennis, that answers you. As the name suggests, supervise requires some supervision, which is in the form of labeled information. That means, people or systems are telling the computer, hey, this is what this is. And that's how the computers learn. Unsupervised, on the other hand, do not require that or are not given that information. So I think Victory, there was a similar question earlier in terms of Python libraries that are useful. So as a beginner, typically people go through a few libraries that could be useful for you. Number one is NumPy, which helps you in numerical Python. Number two is Pandas, that helps you with some data manipulation, transformation, cleaning of data, basic data visualization as well. And then you have things like Matplotlib, Seaborn, which are data visualization packages in Python, and then scikit-learn for machine learning. Now, these kind of form some of the base libraries that you should know so that you build your foundational understanding. And then you can definitely learn other specialized libraries for different things. Now, Python has thousands and thousands of libraries that are created by open source creators, community developers, and you need to know what you want to do to choose the right library, right? So hopefully, Victory, that helps you out. All righty. I think that kind of brings us to the end. There are, numerous sources where you can learn data science from. I mean, there are numerous books available. Uh, you could always get a list from Kelly offline if you wanted. We can put up a list of books on the description of the live stream as well. And also, if you're interested, you could reach out to any of our counselors. They can help you out, and they can tell you how to learn data science better, right? So thank you everybody for joining us. Thank you, Kelly, as well. It was a wonderful interaction with you, and hopefully all the participants had a great time. Your presentation was amazing, and your insights were very valuable. So thank you once again to all the participants who joined us from around the world. Have a very good evening or good day, and take care. And we'll see you all in our next webinar. Thank you.